So, all right, 1.3. We'll take a look at lines, and we'll start out with slope. Slope is the steepness, or the vertical change divided by the horizontal change, which gives you the steepness of a line. Positive slopes will go up and to the right. That's a positive slope. M is for slope. Negative slope, of course, would go down to the left. A perfectly horizontal slope would have a slope of 0. And finally, a vertical line would have a slope that is undefined. And the way you find the steepness is the change in y over the change in x. In other words, you take the y2, you subtract the y1, that's your vertical change, over your x2 minus your x1, right? So there's your slope equation. Let's go ahead and use the slope formula for these 2 points. I've got -1, 3, and I've got 2, 4. So you guys tell me right now, is that slope going to end up being positive, negative, 0, or undefined?
It's positive.
Good, goes up and to the right. Good. All right, let's go ahead and find what it actually is. So I'm going to name it x1, y1, x2, and y2. And I'm going to go ahead and punch it into my slope formula. Let me take it up here. So y2 is 4 minus y1. So if y2 minus y1, 4 minus 3, over x2, whoops, that's supposed to be x2, sorry about that, minus x1. So we got 1 over 2 plus 1 is 3. So our slope is a positive 1/3, meaning this goes up 1 for every right 3 it goes, right? Up 1, right 3. Do a couple more here. We got 4, -1. And we got 3, -1. So if I draw the line through those 2 points, what do you think my slope's going to be? Any takers there?
Neutral.
That's 0. Good, Megan. I typed in. I just saw her chat there on the other screen. 0, that's right. So let's go ahead and check it. x1, y1, x2, y2. Let's make sure it's perfectly horizontal line. I'm sure you can probably tell that it is because the y values are the same, but let's punch it in. y2 is -1 minus, so -1 minus -1 over 3 minus 4. x2 minus x1. So you got slope is -1 plus 1 is 0 over -1. 0 over anything is 0. So sure enough, that is a flat. In other words, there's no steepness. The slope is 0, no steepness. All right, last one. 3, -2, oops, and 3, -5. This one is perfectly vertical, so the slope will be
undefined.
Good. x1, y1, x2, y2, y2 minus y1 over x2 minus x1. Notice you got -5 plus 2, -3 over 0. Cannot divide by 0. Slope is undefined. So there's the algebraic look at that. All right, so just as a recap, slope is your vertical change over your horizontal change, or y2 minus y1 over x2 minus x1, and it's how much you rise over how much you run, right? All right, let's take a look at slope-intercept formula. So here's y equals mx plus b. M is our slope. M is our slope. B is the y-intercept. That's what that B stands for. So any linear function will be of this form, f of x. F of x is just a nickname for y. F of x equals mx plus b. Y equals mx plus b. F of x is just y. Another formula is the point slope formula. This is handy when you have a point. You have a point on the line and you have a slope m. You plug in x1, y1, and m, and you have an equation for your line. Okay. So let's go ahead and write the equation of the line here for this one. You're given the slope. So I'm going to say, okay, I know my slope is 8. And I go through the point 4, -1. Here's my x1, y1. And let's go ahead and draw that too. I have a slope of 8, or 8 over 1. So that's my rise, that's my run. So I'm going to, and it also goes through the point 4, -1. So if I was to draw this, rise 8, so I go up since it's positive, and run 1, right 1. So I go up 8, 1, 2, 3, 4, 5, 6, 7, 8, and right 1. And that's my next point, and I can draw that pretty steep line because it has a slope of 8. But let's go ahead and write the equation for it. Now you kind of have a visual of this. Let's go ahead and write the equation. So I have a point and I have a slope. I'm going to use point slope form first. And I'm going to plug in x1, y1, and m. y1 is -1. My slope is 8. X minus the x value, which is 4, x1. So I have y plus 1 equals 8x minus 32. Let me bring that over here. And I'm going to go ahead and subtract 1 from both sides. So I have 8x minus 33. That's the equation of that line. All right, so there's the work there where we're plugging in the x1, the y1, and the m into point slope form, and then we worked it out to finally get our slope intercept. All right, let's keep going here. Passing through, I have 2 points. So I go through -3, 6, and 3, -2, all right? So I should, what would my slope be if my line is directed that way?
Negative.
That's right. Yeah, so we got to find it. We don't have we have to have a slope and we have to have a point in order to write the equation of the line. So number 1, go ahead and find the slope first since it didn't give it to us. So we got -2 minus 6 over 3 minus a -3. So we got -8 over 3 plus 3 is 6. So we got -4/3. So notice we have a negative slope. So now we have a point and a slope. We have the point -3, 6. We have a slope of -4/3. Get rid of this here. Get rid of this junk up here. Get it out of the way a little bit. Now we're going to use point slope form. Y minus y1 equals m, x minus x1. Here's my x1, y1. Y minus 6, my slope is -4/3. X minus the -3. -4/3 times a +3 is let me write it out. Times that +3, all right? So I got -12/3. So y minus 6 is -4/3 x minus 12/3, so -4, and then I add 6. Y equals -4/3 x minus 4 plus 6, so plus 2. All right, how about if they... So on this one we have an x-intercept. It crosses my x-axis at -1/2. So right here. So that's a point, right? That's the point -1/2, 0. My y-intercept is 4 right here. So they're just giving me the point 0, comma 4. Now I have 2 points. And so I can find the slope. And then write the equation of the line from having a slope and a point. So y2 is 4 minus y1 is 0 over x2 minus x1. So I got 4 over positive a half. So I'm going to multiply by the reciprocal of a half, 2 over 1, top and bottom. So I got my slope. Slope ends up being 8. So this is pretty steep, right? It goes up 8 over 1. Slope of 8. So now I have my slope. And I don't really want to use negative 1/2, 0. So I'm going to use Megan's suggestion. I'm just going to use 0, 4 as my point this time. I could use either one because they're both on my line. So y minus 4 equals 8, x minus 0. And see how that's much nicer to work with. Add 8 to both sides, so we got 8x plus 8. That's nicer than dealing with that fraction, negative 1/2 in my opinion. So, all right, horizontal and vertical lines. So a vertical line, remember a vertical line has a slope of 0, horizontal line has a slope as, a vertical line has a slope that's undefined, the horizontal line has a slope that's 0, but we're going to write the equation of those lines. So let's write the equation of a vertical line containing the point negative 2, 3. So it's a vertical line. Let me give you a table of values. It has the point negative 2, 3, but it's vertical. In fact, let's put more values on here besides negative 2, 3. Like negative 2, 1 is another one, or negative 2, 5 is another point on the line, or maybe negative 2, negative 1, or maybe negative 2, negative 2. Anyways, all of these, what do they have in common here? Well, notice all these points have an x value of negative 2. So that's the equation of this. X is negative 2. That's it. So a vertical line will always be x equaling the constant wherever it's at. Like if we had a different one like right here, it's just x equals 4, right? It's every x value, all of those points have an x value of 4. X is always 4 for that green one, right? Let's write the equation of a horizontal line containing the point 5, 4. Now it's horizontal, right? So let me give you a few table of values. We know 5, 4 is on there. Let's do, how about 1, 4 is another point on there. How about 2, 4 is another point. 3, 4, 0, 4, negative 1, 4, and so on. Oops, negative 1, 4. And what do you notice here? So all those y values have are 4. So the equation of a horizontal line is y equals that number. Y equals 4. Now with horizontal lines, you could do it another way. Since it's horizontal, the slope is 0, and you do have a point. So with this one, you can't do this with vertical lines because vertical lines, the slope's undefined, but you can with horizontal. Again, the slope is 0. Here's your x1, y1. So you could go through point slope form and finish this. Y minus 4 equals a slope of 0. X minus 5. Well, 0 times anything is 0. So you got y minus 4 equals 0. Add 4 to both sides. There it is. So that's the other way you can do that. Y equals 4. All right, let's go ahead and write the following in slope-intercept form. Identify the slope and y-intercept. F of x, just a nickname for y. We'll get into function notation later, so I'm going to write it. Y equals 3/4 x minus 3. Slope-intercept form is y equals mx plus b, so y is solved for. M is our slope, b is our y-intercept. So the slope is 3/4, and the y-intercept, actually I'm going to do the y-intercept first, because we're going to use that information to graph it. Number 1, the y-intercept, the b. You take that value with the 3 along with it, so it's negative 3. So the y-intercept b is negative 3. So the y-intercept is the point 0, negative 3. So I would go ahead and I put that on the graph. There's 0, negative 3. And then number 2, from there I'm going to use my slope. My slope here, see how the slope is 3/4? Remember, slope is rise over run. It's 3/4. Rise is up or down. It's positive 3, so I go right. Run is right or left, right? Rise is up or down. If it's positive, go up. If it's negative, go down. Run is right or left. It's a positive 4 on the bottom, so I go right. So I'm going to go up 3, right 4. Up 1, 2, 3, right 4. And I put a dot, and I can draw my line. All right? And just FYI, you can go the other direction. Negative 3 over negative 4, that's still positive 3/4. So I could go down 3, left 4. 1, 2, 3, 1, 2, 3, 4. And see how that's still on the same line there? Okay. All right, let's go ahead and solve this one for y. Get it in slope-intercept form. So 6y equals negative 4x minus 12. You divide everything by 6. So negative 4, 6. That's negative 2/3 x. Minus 12 over 6 minus 2. Here's my mx plus b. So number 1, my y-intercept. Let me put it up here. My y-intercept. My b is negative 2. My y-intercept, in other words, it's the point 0, negative 2. All right, if you were finding the y-intercept, you'd let x be 0, right? So you could also do it that way. And you'd notice that your y-intercept is that negative 2. So 0, negative 2, put a point on there. Our slope is rise over run. Our slope here is negative 2/3. So it's negative on the top, so I go down, and then positive 3, I'll go right. Down 2, 1, 2, right 3, 1, 2, 3. Put a dot. And I could keep going if I wanted. Down 2, right 3, put a dot, right? The alternate direction is 2 over negative 3 is still negative 2/3. So you could go up and left. Up 2, left 3, and put a dot as well. All of those will be on the line that I drew in red. Okay. Let's move on here. We got parallel lines. Parallel lines, if two lines are parallel lines, they have the same slope. For example, let me draw, here's one. Let's say its slope is 2 or whatever. Well, to be parallel, this line would also have a slope of 2, right? And if I called this line y1, I called this line y2, you say y1 is parallel to y2. That's the symbol for parallel, right? Perpendicular lines, on the other hand, perpendicular have opposite reciprocals. In other words, their product is negative 1. So for example, let's say I have a slope, let's say y1 has a slope of, let me go with 2/3. Then to be perpendicular, so they make a right angle, this line would have a slope, it flips it over, so instead of 2/3, 3/2, and it changes the sign, because their product has to be negative 1. So opposite reciprocals, flip the sign, flip the fraction. That's perpendicular. And if I called this one y1, I called this one y2, y1 is perpendicular to y2. That's the symbol for perpendicular. Okay. So let's go ahead and look at this first one here. So we got find the slope of a line that is perpendicular to y equals negative 4x minus 3. Well, this is in slope-intercept form, right? So you have, in fact, let's make a visual of this. You have a y-intercept of negative 3 and a slope of negative 4/1. Down 4, right 1. So here's the line. So what would the slope of that blue line be? Hopefully you guys notice slope would be negative 4, right? Slope is negative 4. So if I had a line that's perpendicular to it, what would the slope of the perpendicular line be? Well, this is negative 4 over 1. So the perpendicular line would have the perpendicular slope would be, flip it, negative 4 over 1, 1/4, and change it. It was negative 4 over 1, now it's a positive 1/4. So the slope of this red line would have to be 1/4 in order for it to be perpendicular. All right, let's go ahead and determine whether the following lines are parallel, perpendicular, or neither. So if they're parallel, they'll have the same slope. If they're perpendicular, it'll be opposite reciprocals, and neither, it'd be neither situation. So I got to find, first of all, I'm going to take this 3x minus 4y, I got to find its slope. So I'm going to put it in mx plus b form. I'm going to put it in slope-intercept form. Divide everything by negative 4. So y equals negative 3 over negative 4 is a positive 3/4. There's my slope. 12 over negative 4 is a minus 3. So my slope is 3/4. Okay? In fact, I'll give you a picture of that. Y-intercept negative 3, up 3, right 4. Okay, there's that first line. Let's do this one, the second one, 8y minus 6x equals 16. I'll do this in black. Add 6x to both sides. Divide by 8. Everybody. 6/8 is 3/4 x. 16 over 8 is 2. So this slope has y equals mx plus b. This has a slope also of 3/4, but its y-intercept is 2. So it starts here at this y-intercept of 2, goes up 3, and right 4. But these babies, whoops, I didn't draw that very well, have got to be what? If they have the same slope, both lines are parallel. Because they have the same slope, right? Now, if they were perpendicular, if the first one was 3/4, the second one would have to be negative 4/3 in order for them to be perpendicular, right? That would be perpendicular. But we didn't do that. It didn't happen. We had parallel. All right, use the given conditions to write an equation of the line that passes through negative 2, negative 7, and it's parallel to negative 5x plus 4. Okay, so let's go ahead and let's make this visual. I have negative 5x plus 4, so which has a y-intercept of 4. Y-intercept of 4, and the slope is negative 5 over 1. So down 5, right 1 from there. Down 5, right 1. So here's y equals negative 5x plus 4. Now, I need an equation that goes through negative 2, negative 7, that's parallel to it. Well, if it's parallel, it'll have the same slope. So since parallel, slope is also, remember the slope was negative 5 on the first one? Slope is negative 5, and it goes through the point negative 2, negative 7. Well, I have a point, and I have a slope, so I'm going to use point-slope form to write the equation of the red line. There we are, y equals negative 5x minus 17. That's the equation of that red line right there. Okay? All right, a couple more. We're almost done here. Let's have this pass through negative 4, 2, but it's perpendicular to 1/3 x plus 7. So let's draw this scenario. It has a y-intercept of 7. Right, y-intercept is 7, and the slope is 1/3. So I go up 1, right 3, up 1, right 3. Okay, here's this blue line. I need equation of let's do a black line this time, that goes through negative 4, 2, but it's got to be perpendicular. It's got to be perpendicular. I'm trying to come up with the equation of the line that goes through negative 4, 2, but it's perpendicular, right? So it goes through negative 4, 2 right there and perpendicular. Well, the slope of the blue line was 1/3. So since it's perpendicular, the slope of the black line would flip that over. Instead of 1/3, it'll flip it over 3/1, and it'll change the sign. So my slope is negative 3, and it goes through the point negative 4, 2. Now I can write the equation. Y minus y1 equals m, x minus x1, y minus 2 equals negative 3, x minus the negative 4. Distribute that, add 2, and there's the equation of the black line that's perpendicular. Now, last question. This time, I'm perpendicular to a very awkward x plus 7, y minus 12 equals 0. So I'm going to solve for y here. Let me subtract x both sides, and let me add 12 both sides before I do anything. So 7y equals negative x plus 12. I'm going to divide everything by 7. So negative 1/7 x plus 12 sevenths. And so this is pretty awkward to draw, but you're up 1 5/7, 12/7, and then you're down 1 right 7, so it's kind of like that. And we're trying to draw the equation of the line that goes through 5, negative 9, but it's perpendicular. But again, this is kind of a mess because I've got fractions. Well, it's perpendicular, so I take the original slope, negative 1/7, and I flip it over and make it positive. And I go through 5, negative 9. So here's my x1, y1. And I can write the equation. Y minus y1 equals m, x minus x1. So we get 7x minus 44 is that perpendicular line. All right, last example, just an application. The cost of renting a truck is $20 a day plus 50 cents per mile. Well, we're trying to find the equation for this. So let's do it in terms of total cost C to x miles driven, and total cost. Okay, and we're trying to write the equation for the total cost based on x miles. If we drive 0 miles, it's still $20 a day, right? If I drive 1 mile, because it's 50 cents per mile, it's the $20 fee plus 50 cents, so $20.50. If I drive 2 miles, now it's 2 times 50 cents, which is $1 plus 21, $21, and so on. You guys with me on this? So what we have is you can either take 2 points, find the slope, and so on, but you have the cost being 50 cents per mile plus the $20. All right, so 0.5. I really don't need the 0. 50 cents being represented because this is in dollars, right? X is miles, C is our cost. And now let's use it to solve for 160 miles. So 0.5 times 160 plus 20. What's that? 80. Half of 160, so $80 based on the mileage plus the $20 fee. It looks like it costs us $100 to rent this truck. All right. Thanks for watching.